Welcome to our video here on hyperbolic functions. These are functions that you're going to see possibly in some of your college classes. They'll just randomly appear. So I just want to make you aware of what they are, really. So certain combinations of e to the x and the negative x are called hyperbolic functions and have many properties in common with trig functions. So here's what we need to know. I know my copy didn't print out like super nice, so you're not going to be able to see this in the video, but hyperbolic sine, which notes it with a little h at the end, which is pronounced cinch. So sine with an h is cinch. That's going to be e to the x minus e to the negative x all over 2. So that's what that really looks like. Okay. And as far as the graph is concerned, it looks like this. All right, and it's got asymptotes, like e function asymptotes, just like that. All right, for cosh, it's going to be e to the x plus e to the negative x all over 2. And then that graph has asymptotes that look like this. Okay, so that graph actually looks like this. Okay. And then from there, tanh, we can kind of sort of maybe see it on the video. If you have your notes printed out, it's not a problem. Tanh is just sinh over cosh, so then you would just divide those. So it's tanh. There's cotanh, sech, and cosech. Okay, so those are the properties of those. If you take the derivative of these, you can take these separately. It's totally fine. But you'll notice that those properties, the derivative of sinh is cosh. Derivative of cosh is sinh. They're all positive. Derivative of tanh is sech squared, which is, again, in common for what we're used to. You can kind of get the ideas as we go through down here. And same thing for antiderivatives or integrals. Integral of cosh is sinh plus c. Integral of sinh is cosh plus c. And then you get the idea from there. Again, if you have this printed out, it's a little bit easier to go ahead and see this. So let's just do some problems here. So let's go ahead and evaluate sinh of 1. So all you're going to do here is just, sorry, looking through my notes. I do not. Okay. So for sinh of 1, all you're going to do is just plug in a 1 into our equation. So remember, if sinh of x is equal to e to the x minus e to the negative x, then sinh of 1 is going to be e to the 1 minus e to the negative 1 all over 2. And that's it. And usually we don't want have a fraction in there, so this is really e minus 1 over e over 2. We'll just multiply everything by e. I'm going to get e squared minus 1 all over 2e. Okay. And then tanh of ln of 2. So tanh, by the way, is e to the x because it's cosh over sinh, e to the negative x all over e to the x minus e to the negative x. So if we plug in an ln of 2, we're going to end up with e to the ln of 2 plus e to the negative ln of 2 all over e to the ln of 2 minus e to the negative ln of 2. So this e to the ln of 2s, they're just going to cancel out and give me 2s. So that's going to be a 2 plus something, 2 minus something. Now, real quickly, negative ln of 2 is the same thing as ln of 2 to the negative 1, which is the same thing as ln of 1/2. So this is going to be plus 1/2 minus 1/2. So it's going to give me 5/2 over 3/2, which is 5/3. Okay. And now just finding the derivative. And again, we're going to be using these rules right up here. So if I'm going to find the derivative of cosh, I'm using this one right here. So it's going to be chain rule. So the derivative of the inside is 3x squared. Let me use a different color. 3x squared. Derivative of the outside is sinh x cubed. And that's it. Derivative of ln of tanh. So again, derivative of the inside here, and then we do the outside. So derivative of the inside here, tanh again. You can just look at your reference formula here. Is going to be sech squared. So I'm going to get sech squared x times 1 over tanh x. That's really it. There's nothing else we can do there to simplify it, so we'll just kind of leave it. Cool with that. For integrating, now there's no formula that just magically appears here for sinh to the fifth times cosh, but we can use u sub. So if we let u equal sinh x, then du is equal to cosh x dx, and I'm left with u to the fifth du, which is 1/6 the u to the 6 plus c, and my u value was sinh. All right, and the integral here of tanh. Well, there is no formula. I don't see one. So there is no integral of tanh here. If you integrate sech squared, you get tanh, but there's no actual integral of tanh. So what you're going to do here is rewrite this as sinh. I wrote that actually out as sinh. Sinh over cosh. And then we're going to do u sub again. So we're going to let u equal cosh. So du is equal to sinh. So I'm left with integral of 1 over u du, which is ln of u. So this is going to be ln, don't forget that plus c, ln of cosh of x plus c. All right. So those are just the basic properties, just to kind of get you familiar with these. There is actual usefulness into real life. Like, why do these exist? Like, what kind of person thought of this? Just to torture us? Now, hyperbolic functions arise in flexible cables when they're suspended between 2 points, like this right here. Okay, such a cable forms a curve called a catenary. So you can see this picture right here. It's a picture of a catenary. I don't know if you can see this formula really well, so I'm just write it out. So this is the formula here for a catenary. So it's how it's suspended between 2 poles there. So we have a 100-foot wire that is attached at its ends at the tops of 2 50-foot poles that are positioned 90 feet apart. So if I were to draw a little picture here, so these poles are 50 feet. Okay. Have that little guy right there. We know that length of that wire is 100, but yet these are 90 feet apart. Okay. So what we're going to do is we're going to use the arc length formula. So I'll just show you this, and you'll see what the arc length formula turns into. And then when you do problems like this on your daily work, you can just go ahead and use the simplified version. So arc length, by the way, looks like this for those of you that forgot. Okay, so for this problem right here, we know that the length is 100. We were given that. So 100 is equal to the integral from one side to the other. So if we're centered here at 0, I'm going to go from negative 45 to 45. Okay, so we're centered at 0 because the whole length of it we're integrating from here to there. And this is going to be 1 plus, now here's the function right here. Okay, so the derivative of this, by the way, is going to be, so the derivative of this, got a little bit of chain rule right there, is going to be a cosh sorry, a sinh. You know what? I'll do this way. I'll take the derivative. So we're going to do the derivative of that squared. By the way, we can't integrate this from 0 to 45 because it's an even function, as you can see right there. And then the derivative of the inside there is going to be 1 plus, let's see here. Oh, technically, if I want to do the notation correct, I should probably do this. Put little brackets around it. Okay, so this is 1 plus derivative of that is going to be it's actually going to end up being sinh squared, well, sinh of x over a, right? But it's all squared, so we're going to do sinh squared dx. And well, what's 1 plus sinh squared? Now, I didn't show it to you, but it follows the same properties of the trig properties. So 1 plus sinh squared is going to equal cosh squared. No, I probably should show you that. That's not the same that we're used to. See, where's that property? I just need to find that property for you. Or you can just believe me that that's the true property. That 1 plus sinh squared is equal to cosh squared. Again, I'm not asking you to replicate this. I just want you to kind of see it and understand it. So this is going to be cosh squared of x over a dx, which is going to end up being cosh of x over a dx. All right, and then when we do the antiderivative of this, look at mini u sub right there. You're going to get a 1 over a sinh x over a from 0 to 45, which is going to end up giving you 100 equals 2 times, oh, this should be a right here, not a 1 over a. I am so sorry. Coming back from a long weekend. That's not right focused either, is it? Sorry, it's the best I can do. This is going to end up being a sinh 45 over a. So this is the formula that you kind of just need to know how to use. I'm not saying memorize anything right now. Just know how to use it. So pretty much our arc length here, I just want to derive it for you. Our arc length is going to be our wire length equals 2 times a sinh of whatever our pull distance, so distance over 2. That's essentially what's going to end up happening here. And then we're going to use this formula right here, plug everything in, and we're going to figure out how high we are from the middle up to there. Okay? So we're going to go ahead and use our calculator at this point. So what's going to happen is I'm going to use my calculator, and I'm going to graph these two sides and see where they intersect. So for y1, I'm going to get 100. For y2, I'm going to do 2. Instead of a, I'm going to use x, 2x. Now, there is a sinh button on this calculator, believe it or not. It's down here in catalog. If you hit second catalog and you just see that little A in the corner, that means you can hit one of the green buttons that will get you there. So if I hit S, which is right above ln, it'll get you closer to it, but you'll find sinh. You just keep scrolling down, and there it is. So sinh of 45 over x, and then the window here, I know it needs to go at least up to 100, so let's go like 150, and then let's just go out to 100 here as well. You can kind of see it. There it is. Okay. So we're going to find my A value this way. So second, trace, intersect. So my A value here is like 56.009 using your calculator. Okay. All right, so now we have that value. We're going to plug it back into my original here. Try to keep it all on the same screen here. So I'm going to have that y equals this 56 number cosh x over that 56 number plus c. And what I want to do now is I want to be able to solve for this c value. So to solve for this c value, I'm going to go ahead and plug in this point right up here. That part of the pole is over 45 and up 50. So because of that, I can plug this in. So y is 50. And the x value I'm moving over is 45. I'm so sorry. I know this is blurry. It's really annoying. See if I can just... Whoa, that's much better. Holy cow. Should have started that earlier. So I'm going to type this in my calculator, this actual value, and then solve for it. So I know that this, remember, if I type in x, it gives me that 56 number. So I'm going to do x catalog. Whoops, I didn't even show you that. So it's one more time. Type in x, you just get that number. So x, second catalog. I'm going to go down to the c's and look for cosh. Wherever you are, there you are. 45 over x. It's going to give me like 75 something. So that's like 75 something. So I'm going to do 50 minus that. So my c value here is negative 25.080. And now since I have that, I want to find the height. So I'm going to plug in a 0 for x and then call the day. And that's it. So I know that from my equation here, we get y equals this 56 number cosh of x over that 56 number minus this 25 number. Okay. And now y of 0 is going to give me this height right here. So it's going to be 56 cosh of 0 minus 25. And then let's say I type that in my calculator. It's going to be 30.930 feet above the ground. So that's how you solve a problem like that. You'll have a problem sort of like similar to this on the notes as well. Again, you can just get to right here, the star, and then just use your calculator for the rest of it. That's all I expect of you. But I just wanted to show you, where this is useful. Not in everyday life, but it is useful, especially for engineers, to calculate some of the stuff, like how long wire they need with poles and all that fun stuff. That's going to wrap it up.